Good afternoon. My name is Don Deneen. I'm a math tutor here at the CBA. I also work at Luers Academy, which is one of the high schools that services CBA. And what I'm going to do is just go through like a little lesson that the kids might see at school itself or here at CBA if they're having difficulties. So what I'm going to talk about today is graphing sinusoids. So what I'm going to start with is talking about graphing this very simple trig function. Y is equal to sine theta. All right, we want to know how to be able to work these things and solve these, but we also want to know what they look like graphically. And to graph sinusoids is really quite simple. So what I'm going to do is I'm going to go through one cycle, or if you wish, one period of a sinusoid. Now sines will always start here, go up, down, and up. And they go up to 1 unit, they'll go down to -1 units, and their period, or if you wish, one cycle, is 2 pi radians. If you wish, you could say 360 degrees. But once you get to Algebra 2, we'll be working with radians more often. When you get to pre-calculus, you'll be working with radians entirely. We start with 360 because quite often a lot of the geometry work starts with degrees and then we slowly move into radians. Now halfway through is a very critical point because that of course is pi radians. The reason that's critical is that this point, and this point are actually answers to the problem. So if you were to solve this equation, those are where you'd find the answers. Now if you're actually doing some analysis of the trig functions itself, the maximum points and the minimum points have other values. But that's a discussion when we start getting into the analysis of this. Now, of course, this is only one cycle. It's called it's a sinusoid. It's a periodic function. This would continue on in both directions for as far as you wish to go. But this part right here gives us most of the information we need. Now, another very critical sinusoid is the cosine function. So it looks very similar. Y is equal to cosine theta, and it's just a little bit different than your sine. It starts at its maximum point. All right, so what's going to happen is it's going to come, and it's going to actually looks like this. The period, once again, is at 2 pi, and right in the middle, of course, is pi, and that is a minimum point. These are maximum points. In this case, you get those two answers in this type of a situation. So your sine, your cosine functions are your most common, but a third function that we do need to talk about is our tangent function. It's another sinusoid, and this one looks a lot different. Tangent, or y equals tangent theta. Y equals tangent theta. And that looks like this. Now, the interesting thing about tangent is sine theta over cosine theta. And it's important to know that at this point right here, at pi over 2, the cosine value is 0. Since the cosine's value is 0, this fraction would be undefined. So what you actually have at this point is you have an asymptote. That also happens here at -pi over 2. What happens there is the cosine value is 0, the sine value is -1, but the fraction is undefined. So what will happen is at this point here, that would be another asymptote. And then when you go and graph your tangent function, the tangent function comes up through here, and this is the answer in that region. Also, hopefully what you notice in this case, instead of having a period of 2 pi, it only has a period of pi. So the tangent is a little bit different function. But if you can deal with your sine theta, cosine theta, and tangent theta, this is the starting point for all of our trig work as we go on throughout the years. I've had the opportunity to work for the CBA for going on to 8 years now, and I have been just thoroughly impressed with the kids, but also the organization. Anytime my kids need help, I teach at Luers Academy, I can contact CBA and they're back to me right away in terms of when I have access to come in and help with the kids. And with the advantage of some of the kids, if they happen to go to Luers, is they can see me after school. And then I see them at least twice a week and maybe even more this year. And what's nice about the fact I've also taught at Xavier High School, which is another one of the schools that services the CBA, and I'm very familiar with all the schools, right all the way down to Winnebago Lutheran and Fond du Lac. So I know these teachers, and anytime they have trouble, I can contact literally colleagues of mine that I've had in the past and say, hey, Joel's having some trouble here. What's going on? So not only can I get the information from the kids, but I do have the working relationships with a lot of their teachers. So I can call them up and say, hey, how can we help? And that's really what we're here to do at CBA, is help these kids. And for me, it's just a wonderful experience working with these motivated students. Be perfectly honest, I know at Luers Academy itself, I believe the fact that the CBA students are there has lifted our academic standards, simply because our CBA kids are focused students, and that is just very appreciated. And I really appreciate this opportunity. Thank you.